Welcome viewers, in this video we will see the solved problem based on the Thevenin theorem contain AC circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic. Use Thevenin theorem and find the current through 5 plus 4j ohm impedance in the network. We need to find the Thevenin's theorem. By using Thevenin's theorem, we need to find the current flowing through this impedance. So the circuit is available here. The bridge circuit is given. The voltage source is AC voltage source, 100 voltage with 0 degree. Right? This 10 ohm, 8 ohm, 8 ohm and 6 ohm. The terminal AB is called a load terminal. This load impedance 5 ohm and J4, resistor and inductor connected, 5 plus J4. So this is the terminal AB. So the Thevenin equivalent is nothing but V Thevenin connected in series with the Z Thevenin. V Thevenin is nothing but open circuit voltage. This terminal A and B is open circuited and voltage across AB is nothing but V Thevenin. Then Z Thevenin is nothing but the Z Thevenin is nothing but the impedance available across AB by removing the sources. By removing the sources, the impedance across AB is nothing but Z Thevenin. So V Thevenin connected in series with the Z Thevenin. Thereafter, we can easily calculate the current flowing through this impedance, load impedance AB. Right? So first we will find the V Thevenin. For V Thevenin, we need to disconnect this load impedance 5 plus J4. We need to remove this because V Thevenin is a open circuit voltage. The load terminals are open circuited and voltage across AB is nothing but V Thevenin. So that in order to find the V Thevenin, we need to disconnect the load impedance 5 plus J4. So after removing, we will see what is the circuit diagram. So this load terminal is now open circuited. Our aim is to find the voltage across AB. Right? So by using the loop analysis, KVL, Kirchhoff's voltage law, we can find the voltage across AB. For that first it is connected, this is treated as loop 1. This is the loop 2. The current in the loop 1 is I1, the current in the loop 2 is I2. So first we will find the current so that we can find the voltage across AB. Our final aim is to find the voltage across AB, VAB, that is nothing but V Thevenin, open circuit voltage. The load terminals are open circuited, that is terminal AB. The voltage across AB is nothing but V Thevenin. Our aim is to find V Thevenin, VAB. Before that, we will find the current. So this is the loop 1, this is loop 2. By using the matrix method, we can find the current value. This is the voltage matrix, current matrix, resistor matrix. V equal to I into R. So this is nothing but R11, R12, R21, R22. R11 is nothing but total resistor available in the loop 1. In the loop 1, this 10 ohm and 6 ohm is available. So 10 plus 6. Then this R12 is the resistor available commonly between loop 1 and loop 2. See, this 10 ohm and 6 ohm available in loop 1 as well as loop 2. This 6 ohm and 10 ohm commonly available between both the loop. So 10 plus 6, 16. Other than diagonal, remaining we need to write the negative value. Similarly, R21. R21 means the resistor commonly available between second loop and first loop. That also same. The 6 ohm and 10 ohm is commonly available, minus 16. Then R22. R22 is nothing but the resistor available in the second loop. This is the second loop. So 8 plus 8 plus 6 plus 10. Right? So 16, then 22 plus 10, 32. Then the current is I1, I2. The voltage source in the loop 1 is 100 with angle 0. In loop 2, there is no voltage source, 0. So that 10 plus 6, 16, minus 16, minus 16. By adding this 32, I1, I2, 10 with angle 0 and another one is 0. So this is nothing but our delta value. This KVL method separate video available. Right? Separate video available for KVL and KCL. So this is the del value. 16 minus 16 minus 16, 32. So we need to find the determinant value. 16 into 32 minus of minus 16 into minus 16. So already 3 minus available. So finally we will get minus only. 16 into 32, 512 minus 16 into 16, 256. So finally the delta value is 256. Right. Then we need to find del 1. Del 1 is nothing but the first column is replaced by the voltage matrix. See, this first column is replaced by voltage matrix. If we replace second column, that is delta 2. Right. So here the first column is replaced. So 100 into 32 minus 16 into 0. So that becomes 0. So only 100 into 32, 3200. Now the delta 2. Delta 2 means we have to replace the second column. The second column is replaced by voltage matrix. So 16 into 0, 0 minus 100 into minus 16. Already here minus is there, here also minus, so 1600. From that we can find I1 and I2. I1 is delta 1 divided by delta, 3200 divided by 256, 12.5 ampere. I2 is delta 2 divided by del, 1600 divided by 256, 6.25 ampere. Right, now we calculated I1 and I2. Now we need to find what is the voltage across AB. That is our final aim. Our main aim is voltage across AB. So V Thevenin is nothing but VA minus VB. Voltage drop across A minus B. What is voltage across A? Is 10 into 1 I1 minus I2 minus 8 into I2. Right. So this 10 ohm is available in the terminal A. 8 ohm is available at terminal B. This terminal A, the I1 minus I2 is flowing. But in terminal B only I2 is flowing. So that 10 into I1 minus I2 minus 8 I2. So 10 into 12.5 minus 6.25 minus 8 into 6.25. So the final value is 12.5 voltage. Right. So the V Thevenin is the voltage across AB, that is VA minus VB is 12.5 voltage. So we will see the detail about how it is V Thevenin equal to VA minus VB. So here this terminal is removed. So the voltage across this 10 ohm minus voltage across this 8 ohm is the voltage across VA and VB. So in this 10 ohm, I1 as well as I2 both are flowing. So that 10 into I1 minus I2. In 8 ohm only I2 is flowing. So 8 into I2. So that we are calculated VA minus VB, that is 10 into I1 minus I2. Because this 10 ohm is connected between loop 1 and 2. I1 also flowing, I2 also flowing. Both are opposite direction. So 10 into I1 minus I2. But in 8 ohm only I2 is flowing. So that it is minus 8 into I2. So that is available. VA minus VB, 10 into I1 minus I2 minus 8 into I2. So finally we got 12.5 voltage. So the next step we need to find the R Thevenin. What is R Thevenin value? Is nothing but open circuit. This terminal AB is open circuited and the resistor across AB is nothing but R Thevenin by removing the voltage source. This voltage source is now removed. We need to find what is the voltage that resistor across A and B. Right. So this circuit is now simplified like this. This terminal A, B, C and D. So 4 terminals are available. So equivalent circuit is given. Terminal A we have 10 ohm and 6 ohm because here current is diverted. Both are connected in parallel. Here again the current is diverted. So these two 8 ohms are connected in parallel. C and D is the common terminal because it is short circuited. C and D is short circuited. So this 10 ohm and 6 ohm is parallel. This 8 ohm and this 8 ohm is parallel, that is connected in series. Right. So that R Thevenin, RTH equal to these two are connected in parallel. R1 into R2 divided by R1 plus R2. 10 into 6 divided by 10 plus 6. Similarly 8 into 8 divided by 8 plus 8. So that 60 divided by 16, 64 divided by 16 is 7.75 ohm. So R Thevenin is nothing but the resistor across AB by removing the voltage source. So voltage source, removing voltage source means short circuit. So this circuit is simplified like this. Terminal A these two are connected in parallel. At terminal B, these two are connected in parallel. C and D is short circuited. So that these two are parallel, that is connected in series. So after simplification we got 7.75 ohm. So we calculated R Thevenin also. Now we'll draw the Thevenin equivalent circuit. So the third step is we need to draw the Thevenin equivalent circuit. Thevenin equivalent circuit is nothing but V Thevenin connected in series with the R Thevenin. This is the terminal AB. It's a load terminal. In that 5 ohm and 4J is connected. Resistor and inductor is connected. Now see this, the circuit is now simplified. Only one voltage source and R Thevenin and the load impedance. Load impedance is available. So that we can easily calculate the current flowing through this load terminal. I equal to V by R. V is V Thevenin, R is nothing but Z Thevenin plus ZL. So that we are calculating the Thevenin equivalent circuit. Contain one voltage source in series with the resistor. This V Thevenin is calculated by removing the load terminals, that is a open circuit voltage. This R Thevenin is nothing but the resistance across AB by removing the sources, all the sources. Right? So finally we draw this circuit. Now from this you can easily calculate IL. Our aim is to find the current flowing through this load terminal 5 plus 4J. So that is equal to I equal to V by R, V by Z. V Thevenin divided by Z Thevenin plus ZL. It is simplified now. So 12.5, V Thevenin is 12.5. R Thevenin we calculated 7.75 plus 5 plus 4J. That is a load impedance. That is 12.5 with angle 0. By adding these two, 12.75 plus 4J. Now we need to find the final value. So 12.5 angle 0, this rectangular form is converted into polar form. By using calculator we can easily calculate 13.36 with angle 17.47. Otherwise how to calculate square root of 12.75 plus square of 4 will give 13.36. Tan inverse 4 divided by 12.75 will give the angle. Right? Angle is calculated tan inverse 4 by 12.75. Magnitude is calculated square of 12.75 plus square of 4. Right? So here it is given directly. Using calculator also we can find. Otherwise using formula also we can find. So by dividing by these two we got 0.9356 ampere. This angle is nothing but 0 minus. Divided mean angles are subtracted. Multiplication mean angles are added. So 0 minus 7.47. So it is minus 17.47 ampere. So the current flowing through the load terminal is 0.9356 with an angle of minus 17.47 ampere. Right. So in this video we discussed Thevenin theorem. Using Thevenin theorem we solved the problem. We calculated the current through the load impedance. That is by drawing the equivalent circuit, Thevenin equivalent circuit. V Thevenin connected in series with the Z Thevenin or R Thevenin. Finally we calculated the load current. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.